If you've ever been frustrated because you have a big water bottle that doesn't fit in your car cup holder, then you are not alone. I am one of those people who's been using a Yeti water bottle for the past 5 years, and I do get frustrated sometimes because I can hardly ever find a car that can fit my water bottle comfortably. But you don't need to be dismayed because I have a solution for you. If you own a 3D printer, then you will be able to easily 3D print a solution that will work perfectly for your car and your water bottle. And in this video, I'm going to walk you through the exact steps that you can take to design that solution. So if you have a 3D printer, but you don't have any experience using CAD, using Fusion, then this video is going to be perfect for you. Because there are a lot of existing solutions out there. A lot of people have made water bottle cup holders. This isn't a novel idea, and a lot of people have run into the same problem with a really big water bottle. But the issue is there might not be an existing design that fits your water bottle or that fits the cup holder in your car. Because as we know, every car is going to be a little bit different. Every water bottle is going to be a little bit different. So I would encourage you to design your own solution and to not be intimidated by that if you've never done it before. Because once again, I'm going to walk you exactly through the process, and you're going to feel confident by the end of this video that you can design your own solution. And the reason that it's better to design your own 3D prints is because you get so much more control and flexibility. For example, you can design things that aren't existing already on Bamboo Lab or Maker World or Thingiverse. You can create custom solutions for yourself. You can also add the features and the style that you like, and you can easily go back and change or update your design at any time. So if you get a new car, you get a new water bottle, it's going to be so easy to just go and update your design for your new situation. So I would strongly recommend learning the skill of CAD design. And if you have a 3D printer, it's definitely going to pay off. Now, having said that, let's go down to the car and I'll show you the first step, which is going to be taking your measurements. All right, we're here in the car. This is a Toyota Corolla 2016, and I'll show you what I'm talking about with my water bottle. Obviously, this cup holder is much too small, so can't use it. And so we just want to get some measurements for this cup holder, and it's a little bit tricky because it's actually tapered. So I could take my calipers and I could measure the outside of this cup holder, which is still a little challenging because the seat raises up higher than the cup holder. But I can get a decent measurement near the top. If I just push the seat down, go right there. Okay, 3.325, I'm gonna guess. Sounds about right. But the issue is I can't get the calipers in to measure the bottom. So I thought of a little trick that you can do to be able to measure that inside diameter down at the bottom. And what you can do is you can just take a simple piece of office printer paper and curl it up into a little tube. And then when you drop it in here, it just naturally wants to open and touch all the edges. And the easiest way to get this measurement is to take the top of the paper, and you're basically just going to put your finger right at the overlap so that the overlap is flush at the top. And that means that at the bottom, the paper is also going to be touching the edges. And then you can take a little piece of tape and just tape the paper at the top. So I'm pushing the edge down. And the reason this works is the paper wants to open up at the bottom and expand to fill the space. And if you let go of the top, it'll just fill the whole space in kind of like a cone shape. But that's going to be hard to measure. So if I just press at the top to keep things flush, then I know the paper is going to be a cylinder all the way through instead of a cone. So let me just get this nice and flat. And once I'm happy with the position, I'm going to place the tape on. Just go over the top. Now when I pull this out, this end's still loose. but I know that when I align it so that the end is flush, I've got a perfect cylinder instead of a cone. And what I can do is take a pencil and mark where that edge overlaps. I've got a little pencil mark right here. And then I can unfold the paper and measure the length of that edge. So that's one trick you can do. Sometimes taking measurements gets really tricky. And then lastly, the measurement that we need. So we got the top diameter, bottom diameter. Lastly, we just need the depth of the cup holder. And once again, this is a little tricky because the depth changes depending on which edge I measure off of. And I want to know the shallowest depth. And that's because I don't actually want my cup holder to touch the bottom here. I want to make it a little shallower than the shallowest part. So I'm just going to look around till I see the shallowest point. Looks to be about here. And I'm going to take my measurements. And I'm getting 2.875 is what I would guess. So got those measurements there. And lastly, we just need the water bottle measurement. Okay, so we got our piece of paper. And we taped it at the top, and we marked the overlap where the paper forms a perfect cylinder. So now we can undo the tape at the top, and it doesn't really matter if you rip the paper a little bit up here because we don't need the top section anymore, but I'm going to remove that piece of tape. And now we know that the measurement from this edge of the paper to that mark we made is the circumference of the bottom of the cup holder. And we know that we can convert circumference to diameter really easily just by dividing by pi. And it looks like this measurement is too large for my calipers. And I could use a ruler, although the ruler is only going to be accurate to 1/16 of an inch. And I actually think I'll have better success by making a random mark kind of halfway through here. And I can measure from the edge of the paper to this mark. And then I'll measure from that mark to the edge of the paper. So we are propagating some measurement error with every technique that we're using, but I still think we're going to be accurate, more accurate than the ruler method or any other kind of guessing method that I could come up with. Okay, I'm measuring to the left edge of that pencil mark I made, and I got 4.636. And then I'm measuring from the left of this mark I made to the end of the mark right here, and I'm getting 4.503. So now if I add those two numbers together and divide the whole thing by pi, I'll know the diameter of the inside of that cup holder. All right, and then the next important part is getting a measurement of the water bottle. And I'm going to measure at the base because that's the part that's going to sit inside. And I'm just going to have to come from this top angle. And I'm just trying to find the very widest location, 3.764. All right, I've got Fusion open, and I've just opened a new untitled design, and we're now going to design our cup holder. So first thing I know about this cup holder is that it has circular symmetry, because a water bottle and the cup holder both have circular symmetry. So my thought is I can do this easily in one sketch and then do a revolve feature around an axis. Anytime you're designing something with circular symmetry, always look for the opportunity to do a revolve feature. It's going to be much simpler. So let's open up our sketch, and we'll sketch this in the front plane. And because I know I'm going to be doing a revolve, I'm going to start by making a center line. And center lines are really efficient for revolve features. And you'll see why as I go through here. And then I'm going to grab the line tool, this time no center line. And I'm going to draw roughly the geometry that I want. So this is going to be the bottom of my cup holder. I know it has a tapered edge up to the top. And then I could have it go straight out by 90 degrees, but I know that's going to be difficult to 3D print. So I'm going to throw another taper in here, and then I'll go up to where the water bottle is going to sit in here. connect it back to my center line. So you can roughly see what this is going to look like. I'm just going to revolve it so that you can visualize what I'm seeing in my brain. And I hit OK. So obviously the dimensions are not correct here, but this is more or less what I'm envisioning. Water bottle sits in here, then this sits inside my tapered cup holder. So let's go back now and edit the dimensions. So right click, edit sketch, and we'll start by using those measurements that I took earlier. So the first measurement, I'll just start at the bottom here. I'm going to hit D for my dimension tool, and I'm going to dimension from this point to the center line. And because I selected the center line, it'll let me do a full diameter. And this is where we had used that paper measurement, where we rolled the paper up, got the circumference, and then I measured 2 segments of that length using my calipers and divided by pi. And the number that I got was 2.909. And I actually want this to fit kind of tight. I want to press it in to my cup holder and have it sit in there tight with friction. So I'm actually going to add just a little bit on here, and we'll do 20 thousandths of an inch. Make that kind of tight. And next we'll go to the top portion of my cup holder. So point to the center line. It'll let me do the diameter. And this one I'd measured as 3.325. So I got 3.325. And once again, I want this to be a little bit tight. So I'm going to add 20 thousandths of an inch. Okay. And now we'll do the depth of the cup holder. And I had measured 2.875. So that would be from the top to the bottom. Drag this straight out to the right. We got 2.875. And I want this to not touch the bottom of the cup holder. I want it to hover a little bit and just sit in there tight from the friction in the diameter. So I'm going to subtract out a little bit. And I'm going to give this, let's go a quarter, I'll go 0.2 inches of space in there. Okay, so that's our cup holder region. Now let's do the water bottle portion. So I click this line and the center line, and I'm going to do the diameter of my water bottle. And I had taken a few measurements, and the one that I feel most comfortable with is 3.765. So drop that dimension, go 3.765. And I want to give this a little bit of space so it's not like, I don't have to like press my water bottle into it. I don't want a friction fit here. So I'm going to add a little bit of space, but not too much because I still want it to fit tight. I'll do add 20 thousandths of an inch. Okay, now I can set the thickness of the outside of this cup holder. This is way too thick right now. I essentially want to go with the smallest thickness that I feel comfortable with, that'll be structurally sound. I'm going to try a 1/4 inch. I think that'll be good. And then this angle right here, like I said, it would look nice to have it 90 degrees, but then the overhang is going to be too big to 3D print because I know the bottom of my build plate is going to sit here. So I know that 45-degree angles print really well. And so I'm just going to go with a 45-degree angle, keep it simple. That still looks nice. And now I'm going to set the depth of the water bottle portion. So I don't want this to be too shallow or my water bottle is going to fall out. And I don't want it to be too big or it's going to look really bulky and take up too much space. So just looking at my water bottle, I think that 1.5 inches is going to be a really nice sweet spot. That should hold it nice and secure. And now lastly, the only thing that's undefined is this measurement right here. So you'll see if I drag it down too far, then it's going to create some weird impossible geometry right here because this wall thickness is going to go to 0. And if I go too far up, it just becomes bulkier and more high profile. So I essentially want the minimum thickness here that I feel comfortable with. So I'm dimensioning this diagonal right here, and I feel like a 1/4 inch is going to be sufficient thickness while still keeping it kind of low profile. So I'm going to set that. And then lastly, it's going to still show that my sketch is undefined over here, and that's because my center line can still move freely. So I'm just going to tie it down by using a horizontal constraint with this point right here. And now you can see with the lock symbol that everything is fully defined. So now when I hit finish sketch, it's going to revolve this cup holder for me. And I want to look at a cross section. So I'm going to do section analysis, select this front plane, and I'm going to flip it so we can see it and hit OK. And I feel like this is going to take a lot of filament. I could set a really thin, like low percentage infill to save filament, but I also just feel like this is kind of a waste. So I'm going to remove this middle section right here. And I also like that idea because you'll see in a second, it'll create a little storage pocket in here. So I'm going to grab the line tool and draw a line here. I want to get rid of all of this in here. It's just wasted filament, wasted space. So I'm going to add a parallel constraint from this line to this line so that the wall thickness doesn't change throughout. And now all that's left to do is set the thickness of the bottom and this edge. So I've been doing 1/4 inch for everything, so I feel comfortable just sticking with 1/4 inch, which is pretty thick. This should be pretty solid, pretty strong. We'll do 1/4 inch, 1/4 inch. And now you can see I've got this profile on the outside and this profile on the inside. And I don't really need this profile on the inside, so I'm going to go to the trim tool, click, drag, release. Oh, let me do that again. Trim, click, drag, release, and it'll just remove that line. We're still fully defined. I'm going to hit finish sketch. And now you can see we don't have all this filament in here. So this is going to save filament. I'm going to hide my cross section. And what I also like about this is now I have a little storage pocket. I could throw some coins in here, some car mints, whatever, and I get some extra storage underneath my water bottle. And I'm not worried about my water bottle falling through because I know the diameter is much larger than this circle right here. Yeah, the 2.9. So it's never going to fall in here. And I feel really good about this design. So I'm going to go ahead and throw this in the slicer. And in order to get this in the slicer, I'm going to need to save it. I'm going to save this as car water bottle holder. And I'm going to save it in my YouTube channel project. And before we continue, there's one more thing that I forgot. I don't like this flat edge up here. I think we can make it look a little nicer. So I actually want to add a fillet on this edge. So we're going to add a little curve. I'm going to click both of these edges, and I know the thickness is 1/4 inch. So if I add 2 1/8 of an inch fillets, then I'll get a nice, perfect rounded top. And I like that. I just think that looks nicer. I think it's less likely to snag someone's arm or snag on anything. So I'm going to add that fillet there, and I'm going to hit save. And now we're going to export this as a 3D printable file. So select the object that I want to print. I like 3MF, so I'm going to keep it as a 3MF file. I can look at the preview really quick. The mesh looks great. I like that, so I'm going to hit OK. And I want to save it to my computer downloads folder. So I have this box checked, and it's called car water bottle holder. And hit save. That gets saved to my downloads. Now if we hop over to the slicer, I'm using Bamboo Studio, and I'm going to come over to prepare, and let's add that STL in there. So you got car water bottle holder. Hit open, going to click OK here. Great, we want to do one color. OK. And great, it's sitting on the build plate in the location that I want. And that looks great to me. So I'm going to come over. I'm happy with all these default settings. I'm going to come over to preview. It's going to slice it up. And now I'm ready to send it to the printer. Let me just turn my printer on. Okay, the printer's on. So I'm going to hit print plate. And it's going to ask me what filament color I want. And I want this in black instead of white. I think black will look better. Everything looks great. I'm going to hit send. Okay, and that's going to start printing, and then we'll check it out and test it in the car. The print's done. Here we are in the car to test it out. Here's the finished product. You can see that little pocket inside, and we'll just stick it right into the cup holder. And the idea is that it would press in pretty tight, and it's doing that. It is not too difficult to pull it out, but it's tight enough that it doesn't really rotate on its own. I do have to do quite a bit of force to get it to rotate, and also to pop it out takes a decent amount of force. So I'm really happy with that. And especially if you just kind of press into it, it gets a pretty good fit, and then the water bottle fits in nicely. And it's loose enough that when I pull out the water bottle, it doesn't lift the cup holder out of the slot in the car. And there is a tiny bit of wiggle right here. So I think if I wanted to make it tighter, I could play around with that taper a little bit more and get a more accurate measurement. But I am really happy with this, and even if I hit it pretty hard, it's not going anywhere. And yeah, it's gonna work great, and I'll finally have a way to hold my water bottle rather than just having it float around loose in the car. So this is a great project, good beginner design that you can start with. And there are a lot of creative things that you could do to make this better. And if you wanted to really get that taper down, you could 3D print little circles of various diameters and stick them in until you got like the perfect fit that you're looking for. But overall, really happy with it. Thanks so much for watching. Remember to like and subscribe, share this video with someone who you think might like it, and can't wait to chat with you again next time.